Hi, hello everybody. Um, Today, um, I am taking a chemistry course at MUN. That's the abbreviation for Memorial University of Newfoundland in Canada. And today in this video, I'm going to be doing what they're calling a quantum alternate assignment. So the question is written on my board. So it says, calculate the wavelength of the photon emitted when a hydrogen atom undergoes a transition from n equals 4 to n equals 2. Okay, so the first thing we're going to do is so the first thing the first thing that we do is we write down the what is called the Rydberg equation, right? So I have my laser pointer here. I hope you guys can follow my laser pointer. So we have the Rydberg equation is 1 over wavelength. So lambda is the symbol for wavelength, equals the Rydberg constant. And here we have 1 over n final squared minus 1 over n initial squared. Okay, so okay, so the next thing we have is 1 over wavelength equals, so the Rydberg constant is 1.097 times 10 to the 7th. And that's the abbreviation, kind of like saying 1 over meter times 1 over 2 squared minus 1 over 4 squared. Okay, so the next thing I the next thing I did was here basically I'm just plugging things in, right? So here the next thing I did is 1 over lambda equals 1.097 times 10 to the 7th 1 over meter times 3 over 16 because 3 over 16 is this. 3 over 16 is this. And then 1 over lambda equals 2056875 1 over meter, and then wavelength equals 4.862 times 10 to the minus 7 meters. Okay. And that's all. That's all that there is to that. Um, the reason that I picked the Rydberg equation was because when I was doing it on assignments and labs and stuff, and I was looking up ways to do it, I found that in particular, this equation was very confusing, right? And people had different ways of doing it, and the way people were doing it was rather confusing. And so I just want to talk about a little bit about those things, and so just I can briefly just clear up a lot of those misconceptions or those unclarities, right? So the first thing that I wanted to go over with is kind of like the concept. So um, here we have a hydrogen atom, right? And so if we say this is the nucleus of the hydrogen atom, then we have the n equals 1 energy level. So we call that is also called the ground state. And then we have the n equals 2, n equals 3, n equals 4. So in this question right here, it says that the electron goes from an n equals 4 energy level to an n equals 2, right? So if we read the question, it says photon emitted, right? And so emitted means that energy is released. And so if energy is released, that means the electron relaxes. So if it starts at an n equals 4, it relaxes or gets demoted to an n equals 3, then an n equals 2. And so that's a little bit of the basic concepts of that. Okay? So there's a little bit of different ways that people do it, and you want to be careful that about these things so that you don't end up making mistakes when you're doing these problems, right? So the first thing is that some people will, when they're doing it, they'll say that this NF is NI, and they'll say this NI is NF, right? So the problem with that is that if you do the opposite, the wavelength will end up being a negative. And wavelength is a measurement, and a measurement should not really be a measurement should not really have a measurement. Any measurement should not be negative. right? So you should avoid, so you should really avoid doing that. And the other thing is, another thing that confuses a lot of people too is that sometimes people will call NF, this NF here, they'll call it N1, and they'll call this NI N2. And just for clarity, NF, remember, is N final, and NI is N initial. So people will call NF N1 and they'll call NI N2. But the problem with that is that a lot of people, including myself, when they see N1, we think of that as N initial. And when we think of N2, we think of that as N final, right? And the reason that people like me think that is like initial, when you think of initial, that's the first thing, right? So initial is the first thing. So that's where people think of the one. And when you think of final, you think of, things that happened later on, right? So happens later on, two happens later on than one, right? So you have to be very careful with that because if like that doesn't really make sense, and I'll even just show you why it sort of doesn't make sense, because here when I just showed you the explanation, the diagram, right? So just like the question says, is it starts, it undergoes a transition from n equals 4. So when they say from n equals 4, that is an initial. So this n equals 4, when we when it says from n equals 4, that is initial, right? And so that's what we wrote here, is the 4, right? And then we said 2n equals 2. So the n equals 2 is here, n equals 2, right? The n equals 2. So n equals 2 would be the final, right? The n final. And so as we wrote down here, n final is 2, which is 2. So far all this makes sense, right? But if people decide to say that NF is N1 and NI is N2, right? And they refer N1 to, and they refer N1 as N initial, and then they refer N2 to N final, right? So if you think of it as what would be the initial here, right? So the initial would be 4, but it's not 4, it's 2, right? The same thing with this. If we refer N2, if you refer N2 as N final, then N final would be N equals 2. I'm trying to make sure I'm not confusing people. So if we say that N final is N2, if we say that this is N2, that's N final. That's 2, right? Okay. It's not 2. Oh, okay, sorry. I'll just I'll just re-explain that again because I think I sort of made a mistake when I explained that. So when people refer, if people refer this first one to N1, right? And they therefore refer N1 as an initial. Same thing as if they refer, okay, let's just start there, right? If they refer that first one to N1 and refer N1 to N initial, right? So N initial would be 4, but it's not 4. The number has to be 2, right? So here, if they refer this as N2 and they refer N2 as N final, then N final would be N equals 2. But it's not 2, it's 4, right? So you have to be very careful with that. Otherwise, again, you'll be getting a wavelength with that's a negative, right? So the thing is that like a lot of the times people don't purposely refer, like when they just plug in N1 here, and when they plug in N1 here and N2 here, they're not really, a lot of people aren't really referring N1 to N initial and then N2 to N final. They're just putting in just random values, right? But the other way to sort of make sure that you're not making any mistakes um, is that you want to make sure that the number that goes into here, the number that goes into here is bigger, is the bigger number, right? And the number that goes into here is a smaller number, right? So as long as you can remember that the number that you put into here, the number that you put into here is the bigger number, and the number that you put into here is a smaller number, you'll get the correct value. There, that means you'll get the correct value for the wavelength. So therefore the wavelength will be a positive value. If you do it the opposite, then like I said, the wavelength that you get will be negative, and wavelength or any unit of measurement should not be negative, right? So I just hope that I just helped clarify that, because I just see a lot of people doing it and teaching it in sort of confusing ways. So yeah, I don't want this video to go on too long, as I know all you people have things to do. So I just wanted to say thanks a lot for watching, and because this is a YouTube video too, you know, I can't help but say to subscribe and hit on all notifications if you want to, so that by the time I post a new video and then you watch it, it won't be outdated. So I usually introduce myself at the beginning. My name is Danny, so I just didn't want to forget the fact that I could introduce myself. So that's it. So thanks for watching. Have a nice day. Goodbye.